Hello, and welcome to 5-Minute Math. Today we are looking at the 4th grade concept of lines of symmetry. This is standard 4.6b in the great state of Texas, and we are using item number 11 off the 2016 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and then we will look at our answers together. So we've got 4 different figures here, and we need to find one that has exactly one line of symmetry. So we obviously need to define what this term is. So what is a line of symmetry? Well, it doesn't exist. It's an imaginary line. So we're going to end up drawing some lines on these shapes, but it doesn't exist right now. They're imaginary lines that bisect. That's a fancy word we'll define. Bisect a figure. So when something bisects it, you see that word bi, that prefix means like bicycle, it cuts exactly in half. So if I were to draw a rectangle like this right here, I could bisect it, or I can draw 2 different lines of symmetry. I can draw, and usually we'll draw little dashes. So if I draw a 100% vertical line right there, I could bisect or draw an imaginary line that's going to cut this rectangle in half. You can fold one side over. You could also do one that is horizontal, so you can fold the top half down. So that would have 2 lines of symmetry. And so that's just an example. What we're looking for is something over here, A, B, C, or D, that has exactly one, not more than one, exactly one. So we have to play with this a little bit. And if you're doing this, paper and pencil, obviously you can erase, you can play around with it a little bit. I would always try. Now these are slanted lines, so that's going to make it a little bit more difficult. But try kind of like what I did. See if you can cut it in half exactly straight up and down, and cut it in half exactly side to side. So I'm going to kind of pretend like we've got that line right there, and it is kind of a slanted, a rotated figure. So I'm just going to pretend like that's my straight up and down. So that's one line of symmetry. And I can actually do another one right there, which gives me at least 2 lines of symmetry. Sometimes you can do diagonals, but not necessarily here. So this has got 2 lines of symmetry, and we're looking for exactly one. So that is not what we are looking for. So let's check B. So, I can't do that vertical line because look at this ending right here. Is a different shape than this. So I can't fold it from left to right. I can't do that because those 2 would not match up. It needs to cut exactly in half, and the 2 sides need to match up exactly. What I can do is I can draw a line of symmetry right there, because this top half, take a look at this top half right here. If you were to fold that top half down, that's exactly the same shape as that bottom half. So that line of symmetry, imagine folding one on top of the other, that would work. So this might be our answer, because I've got one line. So let's check X. All right, let's check C. We'll get to D, which is the letter X, in just a moment. I'm not really quite seeing anything. I can't do this vertical line, because look at this ending right here. That is definitely different than this end of this figure right here. Those 2 do not match up. And I could almost do an up and down, but as you can see, even this side right here is going to mess me up. If I were to try to do it like this, this part would not match up with that part. So I've got 0 lines right there, nothing. And then D, hopefully you see, has a lot of lines. We could go vertical. We can go horizontal. We can actually go diagonal right here. So I've got 4 lines, but I'm wanting just one. My answer is B.